Hello students, have you ever noticed how a seesaw works? When one side of the seesaw goes down, the other side rises. Or have you ever thought why there are those concrete blocks on one side of the cranes lifting heavy building materials? This has to do with something called as a principle in physics called as principle of moments. The principle of moments keeps the seesaw moving or the cranes at work without causing accidents. The same principle applies to many objects around us, from the door hinges to the spanners. I welcome you all to today's lesson where we will explore how the forces create turning effect and how equilibrium is achieved. Before we dive in, I hope you have seen the first video of this chapter where we had talked about the turning effect of the force. Now let's get started with the new one. To understand the principle of moments, first we have to understand how the directions are assigned to the moments produced by force. You know that in case of linear motion, the directions are given as upward, downward, forward and backward, depending on the direction of the force. Similarly, in the direction of circular motion, it is given as either clockwise or anti-clockwise. For example, here's the wrench moving clockwise, and as we move our hands in opposite direction, it starts moving anti-clockwise. So, a moment is the turning effect of force around a pivot. Depending on the force's direction, the moments can be classified as clockwise or anti-clockwise. It's easy to assign these directions to the turning effect if you directly compare it with the clock hands. Consider a rod being applied with forces as shown. The pivot of the rod is considered as the center of the clock. You can see that the force F1 and F3 would rotate the rod clockwise, whereas force F2 and F4 would rotate the rod anti-clockwise. So, here's a key to remember. Consider the pivot as the center of the clock and imagine how the forces would turn the object in clockwise direction or anti-clockwise direction, and you will be able to easily identify the directions of the moments. We have seen earlier that if one force is applied away from the pivot, it causes turning effect on the body. But what if there are multiple forces acting on the body? Will the body still rotate or remain stable? To answer that question, we need to understand that if the clockwise moments and anti-clockwise moments are equal, the object neither moves clockwise nor anti-clockwise. This steady state of object is called as equilibrium. If the moments are unequal, then the object rotates in the direction of greater moment, that is either clockwise or anti-clockwise. This leads us to the principle of moments. The principle of moments states that when an object is in equilibrium, the sum of clockwise moments equals the sum of anti-clockwise moments. Here's the formula for the principle of moments. It says that total clockwise moment equals to total anti-clockwise moment when the objects are in equilibrium. This means that when there are multiple forces producing different moments on the object, the net turning effect produced by these moments is zero. For example, consider a uniform rod of 2 meter length pivoted at its center. There are two 25 Newton forces applied at two ends of the rod in the same direction. The clockwise moment produced by right side force will be F1 into D1, that is 25 Newton meter, and since the other force is acting at exact same distance from the pivot, the moment of that force will also be 25 Newton meter. Since both of these moments are equal, they balance out each other and the rod will neither move clockwise nor anti-clockwise, and this state of rod is called as equilibrium. Let us now understand equilibrium in detail. A body is in state of equilibrium if it neither moves linearly nor circular. For example, see this rope walker. The rope walker holds a long stick to spread their weight over a larger distance from their pivot point. That's their feet. This increases the moment of their body's weight and helps them balance small tilts with equal and opposite moments. This keeps them in equilibrium. Equilibrium occurs when there is no net force or turning effect acting on the object. For an object to be in equilibrium, the sum of all forces and sum of all moments acting on it must be zero. In IGCSE exams, you get a question that asks, what are the conditions of equilibrium? So your answer should be no net force and no net moment. Now that will give you answer to my questions in the start of the video. The seesaw swings when there is a difference between weights of children sitting on two different ends of the seesaw. Otherwise, it won't swing at all. And the concrete slabs that we see in cranes help them to maintain equilibrium while lifting heavy building materials from one end. These bricks are called as counterweights. So, whether it's a playground, construction sites, or the circus acts like rope walking, equilibrium keeps things stable. Let's apply what we have learned to solve some IGCSE style questions about moment of force. You can see the question on your screen. The question says that consider a rod as shown in figure above. Its total length is 3 meters and it's pivoted at its center, meaning the pivot is here at the center. By considering the forces shown, calculate the value of force F3 that will keep the rod in equilibrium. Now, whenever we get the question about moments, the first thing that we have to check is how many forces are acting on the object. In this case, there are 3 forces acting on the object, 2 on the right hand side, that is F1 and F2, and the third is on the left hand side of the pivot, that is F3. The next thing that we have to figure out is what would be the directions of the moments produced by these forces. In case of F1 and F2, they are producing clockwise moment on the rod, whereas F3 is going to produce anti-clockwise moment on the rod. So, since they have said that the rod is in equilibrium, we have to apply the principle of moments, that is total clockwise moment is equal to total anti-clockwise moment. In case of clockwise moment, there are 2 forces producing clockwise moment. So it will be F1 into D1 plus F2 into D2. And in case of anti-clockwise, there is only one force. So it will be F3 into D3. Substituting the values, F1 is 10 Newton. Its distance from pivot is 0.5 plus F2 is 20 Newton and its distance from pivot is going to be 0.5 plus 1 meter, that will be 1.5. This is equal to F3 into its distance from pivot, that is 1.5 meter. So when I have to calculate F3, it's going to be 10 into 0.5, that will be 5 plus 20 into 1.5, it will be 30 divided by 1.5. So the answer would be 23.3 Newton. So understand that when F3 will be 23.3 Newton, the rod is going to be in equilibrium. Let's go to question number 2. Question number 2 says that 2 students are on seesaw as shown in the diagram. The boy is of mass 30 kg, is sitting at distance 5 meter from the pivot. The mass of the girl is 20 kg. Calculate the distance at which she should be sitting to maintain the seesaw in equilibrium. So they are asking us to calculate the distance of girl from the pivot. So we are supposed to calculate the value of D2. Now here there is a catch in the question. They have not given us weights of the people, they have given us masses of the boy and the girl. And we have to understand that the principle of moments is applied to the forces, not the masses. So we have to understand that in this direction, the weight of the boy will act, that will be mass into gravity, that's 9.8. And in this direction, the weight of the girl will act, that will be 20 into 9.8. And now, again as they said that the seesaw should remain in equilibrium, we will apply the principle of moments, that is total clockwise moment is equal to total anti-clockwise moment. Now, girl's weight is going to produce clockwise moment about the pivot and boy's weight is going to produce anti-clockwise moment about the pivot. So, for clockwise moment we will write the force of the girl's mass, that is 20 into 9.8 multiplied by distance, that's d2, is equal to, for total anti-clockwise moment it will be boy's mass multiplied by gravitational acceleration 9.8 into his distance from pivot, that's 5. So d2 is going to be 30 multiplied by 9.8 into 5 divided by 20 into 9.8. So in this case 9.8 will get cancelled and your answer would be 7.5 meter. So this distance must be 7.5 meter from the pivot, then only the seesaw is going to remain in equilibrium. With these examples, I hope you have understood how to apply the principle of moments in the exam questions. So that's all about the principle of moments. Before we wrap, it's time for Scratch the Brain section. Students, you must have seen people rowing a boat. Consider two people rowing a boat on the opposite sides from the center of the boat. Can you think how should their direction of forces be to decide whether the boat will move forward or take a turn? Scratch your brain on that and I'll see you in the next video of turning effect, wherein we will discuss about center of gravity. Until then, keep questioning, keep learning. Thank you.